This is Lake Mead. It was formed by the Hoover Dam, which was built between 1931 and 1936. If you live in the US, you've almost certainly heard of it. When it was built, it wasn't just the largest dam in the world, overtaking the 1911 Roosevelt Dam, also in Arizona. It was the largest concrete structure ever built, and cost nearly 100 lives over its 5-year construction. The lake formed by this dam, Lake Mead, is the largest reservoir by volume in the United States, and the 28th largest in the world. At least, that's the case when it's full. Cheers. Today, Lake Mead generates about 40% of Arizona's water. Through the Central Arizona Project and the Salt River Project, this and other water supplies are taken and delivered through aquifers throughout Arizona, but mostly to the Central Valley, the Phoenix metropolitan area, which has about 2/3 of Arizona's total population. This network of dams generates about 621 megawatts of power. And sounds like a lot, but it's dwarfed by coal, natural gas, and other fossil fuels, which generates 7.2 gigawatts of power. Now, there are other clean energy supplies such as nuclear, wind, and solar, which generate a combined 3.5 gigawatts of power. And that's not quite the same, but it's getting better. In 2010, solar energy made up about 0.1% of all power generated in Arizona, whereas today, it's almost 7%. Arizona has an ambitious plan to switch to mostly clean energy, 45% by 2030, and upwards towards 100% by 2050. Now, that's an ambitious plan, but this episode isn't about power, it's about water. And with regards to water, Arizona's future isn't quite so bright. All right, first, let's talk about units of measurement. If I asked you to measure a volume of water, you'd probably use liters, or maybe in the US, gallons. If it's a large body of water, such as the one behind me, you'd probably use cubic meters. If you're working in planetary science, you might use kilometers, as in there's 100 kilometers of liquid water beneath Europa's icy crust. But if you're in the US and you work in water management, you use acre feet. An acre foot is an acre in surface area by 1 foot in depth. An acre is a chain by a furlong. A chain is 100 links, 4 rods, or 20.1 meters. A furlong is 10 chains, 40 rods, 201 meters, or 83.75 horses, which is a real unit of measurement. As annoying as the acre-foot unit of measurement is, it is useful for gauging a couple things. For example, an 8-lane Olympic swimming pool has about 1 acre-foot of water, and 1 acre-foot is used as a rule of thumb for the amount of water used by a suburban household in the United States over the course of a year. It's equal to about 1,233 cubic meters in total, and it is a lot of water. But here in Arizona, there are water conservation programs and houses rarely have lawns, so that number drops down to about 1/4 of an acre-foot of water per house per year. So now when I tell you that Lake Mead gets, as a historic average, 8.23 million acre-feet per year from the Colorado River, you might have a rough understanding of how far that will go. That average doesn't mean much these days due to climate change, but we'll get to that in a minute. Since Arizona has a total population of 7.2 million people in around 2.5 million households, it may seem like an ample water supply. But the thing is that Lake Mead doesn't just supply Arizona and its households, but also California and Nevada in the US, and Baja and Sonora in Mexico, along with their respective industries in agriculture, mining, and others. Between 1940 and 2000, the water level of the lake covered at about 75%, or 20 million acre-feet of water. The height level of that water averaged about 1,160 feet. Now that's above sea level, not from the bottom of the lake, which is about 660 feet above sea level. Since 2000, however, that water level has dropped significantly. Currently, at the time of this recording, it's at 1,081 feet, which is just 10 feet above its record low set in 2016, and a total of 39% maximum capacity. At 1,075 feet, a Tier 1 shortage is called. That means that water will be cut to penal county agriculture and to some NIA or non-Indian agricultural allotments, which, despite its name, is predominantly used by tribes and cities. Overall, this isn't too bad. Arizona has had to deal with water shortages before, and we knew it was coming. Arizona is a junior when it comes to water rights. When there's not enough water to go around, California gets priority. This is the result of the original contract negotiation for the Central Arizona Project made way back in 1968. At the time, it stated that California gets top priority on water, and this agreement was made because the Central Arizona Project needed the political and financial backing of California to make it a reality. So, in the event of a water shortage, California doesn't lose a drop, but instead, that water is taken from Arizona, Nevada, Baja, and Sonora. Well, at the time, you can kind of understand their thinking. It was unthinkable that the water level would drop as low as it is today. I mean, Nevada's draw, well, I guess it's Las Vegas's draw, which gets 90% of their water from Lake Mead, was laid at 1,050 feet. That's almost where the lowest water level is in current recorded history, and it's likely to drop even more. So Nevada recently laid down a third draw at 860 feet, well below the lowest recorded level. But it shows you their fears. The good news is that that contract with California is up for renegotiation soon, and it's unlikely that they're going to get such a sweet deal. For one, facing climate change and ever-worsening drought places a huge burden on the water supply, and Arizona, Nevada, Baja, and Sonora really can't gamble with that kind of financial backing, and they really need the water. With the incoming La Nina season bringing dry air and evaporating the snow before it has time to melt into the groundwater and find its way into the reservoirs, it looks like another serious year of drought is on the horizon for the Southwest. Now, 1 year of water shortage isn't enough to be a serious threat, but since this has been happening for year after year, we may be in far more serious trouble, and next year's return to a Tier 1 water shortage might get even worse by 2023, when water levels are predicted to drop even further. If they drop enough, then Arizona would be facing a Tier 2 water shortage, which means that most, if not all, of that NIA allocation I talked about earlier would be cut. And if that fails, then mining and industry allotments and the Indian priority will also be in danger. But Arizonans will be in trouble long before that. During a Tier 2 water shortage, small cities and towns would need to find other sources of water from rivers and reservoirs from around the state, like this one here, the Willow Creek Reservoir in Prescott, with a capacity of about 10.5 thousand acre-feet of water. Prescott is the third largest metropolitan area in Arizona after Phoenix and Tucson, but even so, it has a population of only just under 130,000 people. The Arizona Department of Water Resources authorizes Prescott to use 16,500 acre-feet of water annually, but it used only 6,700 of that in 2019, down from 8,000 in 2004. Despite its growing population and the uncertainty of the Lake Mead Reservoir, it is in an excellent position by itself, being able to pull from a further estimated 2.3 million acre-feet of water just beneath the Earth's surface. But this isn't the case for most of Arizona, especially Native American reservations, which make up 27.1% of the state. They depend heavily on water storage from reservoirs like Lake Mead, Lake Pleasant, and Theodore Roosevelt Lake, the dam for which broke records back in 1911, among others. This robust reserve of surface water is especially beneficial to Phoenix, which has the ability to withstand several years, if not decades, of drought before being seriously affected. That's not the case for many of Arizona's smaller communities, however, which would have to negotiate for water from nearby towns like Prescott and find new sources of water when the Central Arizona Project reservoirs start drying up. Those new sources, such as aquifers and imported water, when combined with water conservation efforts and policies, will likely be enough to sustain these small, remote communities, but would also increase the cost of water and further drive the urbanization of this and other southwestern states. How this will affect the wider economy of Arizona and the Southwest as a whole is uncertain, but it is clear that now, more than ever, water will drive policy, culture, and politics in Arizona for the foreseeable future. And the American Southwest is far from the only region facing looming water crises. Today, 844 million people live without access to clean drinking water. That's 1 in every 50 people. Nations like Israel, India, Qatar, and the UAE are all at extremely high risk of losing access to what little drinking water they already have. And supposedly developed nations like Spain are at risk. But it's going to get worse. By 2050, it's estimated that 1 in 4 people will live in a country without access to clean drinking water. You would think that here, in the richest nation in the world, we'd have the money, the power, the influence, the innovation to do something about it here and now, before it becomes a problem for everyone on Earth. I have a couple links in the description below to UN Water and thewaterproject.org if you want to make a difference or learn more. But let's be honest, the real problem here is that beer is made with 90% water. Cheers. kilometers of water beneath Europa's icy surface. But if you're in the US and you work in the Water Management Agency, you use acre-feet. You're not seeing this right. I'm sorry. We'll try that one more time. So yeah, okay. So you know that